Determining how to allocate or apportion seats amongst the population typically starts with two steps. The first step is to determine what is known as a standard divisor. And the formula for the standard divisor, and this is in general, is, and I'm just going to shorthand it right here, I'm going to write it as SD for standard divisor. That's equal to the total population, and it's an average. So then we divide that by the number of seats. Now the total population is the overriding size of the population of interest, and the number of seats is the number of items to be apportioned. So this problem states, suppose a school district within a metropolitan area received a grant that awarded 50 new computer tablets for use by its faculty. There are 5 schools within the district. Since each school does not have the same number of faculty, the district decides to apportion the 50 tablets according to the size of each school's faculty as shown in the table. And here we can see it here. So here's our table. We have 5 schools, School A, School B, School C, School D, and of course School E. And here's the faculty that work for each one of the individual schools. Determine the standard divisor for this population. So the population here, the total population, is the number of faculty. And we could see right here, there's 450. So that's our total population, our overriding size. The number of seats, well again, that's the number of seats is the number of items to be apportioned. And we want to apportion these 50 computer tablets way up here. So since it's an average, that's what we'll do. We'll simply divide 450 by 50. And 450 divided by 50 is 9. So our standard divisor for this scenario is 9. Now the second step needed is to apportion the tablets to each of the schools. This is known as a standard quota, determining a standard quota. So it says here, using the results from example 1, in which the standard divisor allotted is 9 tablet computers, determine the standard quota for each school. So the formula for this standard quota, again, I'm just going to shorthand it here. I'm going to write it as SQ for standard quota. That's equal to the population of each subgroup. And then we divide this, again, it's another average. We just divide this by the standard divisor. And I'm just going to put down SD for standard divisor. So our subgroups are the individual faculty for each school. A, B, C, D, and E. So then we simply divide each amount of faculty for each school by the standard divisor. This is the population of the subgroup. Our subgroup is school A. We divide that by the standard divisor. 138 divided by 9 is 15.333, and I'm going to put this bar over it. This bar means that this pattern here repeats, so it's 15.3333 indefinitely. And then we do that for each subgroup here. Then we divide this by 9. 103 divided by 9 is 11.444, and this pattern also repeats. For school C, 183 divided by 9. That's 9.222, and that pattern repeats. School D, 47 divided by 9. That's 5.222 with that repeating bar again. And then finally for school E, we divide that by 9. And that's 8.77 and 7, and of course that repeats. So the standard quota for A, that's 15.333333 indefinitely. For B, 11.444 indefinitely. C, 9.222. D, 5.222. And E, 8.777. And of course, if we add all these standard quotas up right here, we add them all up, they're going to equal to 50 tablet computers. However, there's a problem, and the problem is that we can't allot a portion of a tablet. There's fractions here. As a matter of fact, any of the seats, no matter what they represent, we can't have a fractional result. There will be a fractional result when we do the arithmetic, but we can't rely on a fractional result because we can't have a fractional apportionment. So this is where the quota rule comes in, and I'm just going to put it right here. And the quota rule states that the number assigned to each represented subgroup must either be the standard quota rounded down to the nearest integer, also known as the lower bound quota, or rounded up to the nearest integer, also known as the upper bound quota. So we'll do that. We have to follow the quota rule. So we're going to round each one of these values. So 15.333 rounds to 15. 11.444 rounds to 11. 9.222 rounds to 9. 5.222 rounds to 5. And 8.777 rounds up to 9. However, another dilemma occurs. When we go ahead and we add the rounded figures, 15 plus 11 plus 9 plus 5 plus 9, they don't add up to 50. They add up to 49. So that's 49 tablets, so we have one tablet left over. So keep that in mind as we advance to the next examples.